Hi students, let's look at this question here, which is on the techniques of integration for the first part. So we are told to find this integral here. So let me just copy this question here for the first part A. This question was taken from ASRJC, paper 2, question 4, from the year 2020. Okay, this is part A. So in this case here, we're told to find the integration of cot to the power of 6 2x plus cot to the power of 4 2x, okay, minus of sine x over 2 sine 3x over 2 dx. Okay, so this case here, what I will suggest is essentially, you see that these are cot 4 and cot to the power of 6. What we could do is just factorize the cot to the power of 4 out, but this, we have to be very clear, these are the multiple of two trigo ratio, sine and cosine. So this we just use the factor formula from the MF26, right? I'm gonna slowly just separate this. So I'm gonna integrate this on one side and integrate the other on the other side here, and this we can use factor formula. So bring our MF26, and we're gonna find for the factor formula sine. So I usually just there you go, it's over here. So we know that all the expression on the left could be integrated, and all the expression on the right could not be integrated. So but in this case here, we know that sine half p plus q. Just remember that you take this and add with this will give you p. You take this minus of this will give you q. Okay, so we're going to do that quickly. So this case here, I know that cosine p minus cosine q is minus half. I get back at this whole thing here, equals to sine half p plus q sine half p minus q. Okay, so just know that this is your x over 2 and this is your 3x over 2. So you add them, you get p, and you minus them, you get q. Alright, so that's the main thing there. Now this one here, what I'll suggest is just factorize the cot to the power of 4 out first. I will see what we'll get. Cot to the power of 2x plus 1 dx. Alright, then for the second part here, we know that this will just be minus half cosine p, which is adding of these two, would be cosine 2x minus cosine, minus of them would be minus of, right, minus x here. So this would then be 3x, but you can just flip this over to the other side, but I'm going to just do this half minus half, that will be negative x, okay, dx. Great. So once this is done, that's pretty okay. I'm going to factorize this out, and now cot square 2x is very important. You need to know that this expression is not given in MF26, but what you need to know is cosine square plus sine square x equals to 1 divided by sine square or sine square x. This will be cot square x plus 1 equals to cosecant x. Okay, so always have a scribble MF26, because certain formulas are in MF26, certain formulas are not. So in this case here, I'm going to just change this to cot 4 square 2x, and that will be cosecant square 2x dx. Alright, so this we can use this cancelling method here, or the u substitute method. You can just use f prime fx method. So this is cot 2x to the power of 4, and then okay, so that's it. Then after which this will just be plus half cosine 2x, then this will be minus cosine x. Cosine negative x is positive x, right? Just remember that. So I just changed it over here. Negative x equals to cosine x. Okay, so then we can just start integrating. So integrating this wouldn't be a problem. This will just be our u. So this is cot u equals to cosecant square 2x. Then in this case here, we'll get this cot to the power 4. Sorry, let u be cot 2x, because differentiating this will give you cosecant square and we could cancel. So this will just be our u to the power 4 cosecant square 2x. du will be -2 cosecant square 2x. Cancel it out. This will be half sine 2x over 2 minus sine x plus e. And we'll get this as cancel it out. This will be minus half u to the power 4 du. So plus 1/4 sine 2x minus half sine x plus c. So in this case here, very quickly, u is our cosecant cot square. So this is cot to the power 5 2x over 5. Okay. There you go. We just simply, so this case here, we'll get is minus 1/10 cot 5 2x plus 1/4 sine 2x minus half sine x plus c. Okay, so that's how I do this question proficiently. If you have any questions at all, please do let us know. Keep practicing and I'll see you in the next question. So let's look at part B. Part B, we have the diagram shows y equals to 2x and y equals to x plus 1, and R is a finite region bounded by these two curves here. So essentially what we're looking at is this curve here. So meaning we are looking at this area here, right? This area bounded by both of the curves. So maybe I just label this out here. Now the first thing is, okay, so thankfully they have given us this point here, which is the point of intersection. Okay, so this will just be negative 1.2785, and this over here would then be 0.07754. Great. Now find the volume of a solid when R is rotated 2 pi around the y-axis, so it just revolves around this area here, giving an answer correct to 4 decimal place. So if this is 4 decimal places, we don't, please take note, just use GC to evaluate. Okay, don't really need to go through because it's 3 marks only, so you don't need to just do integration there. So let's try and understand how this diagram works. I hope you can see what's the problem here. It's actually quite a interesting shape if you can visualize it rotating about y-axis. So I'm going to just model this out for you. As you could see here, this is where the shaded regions, this is a shaded region here. So we're going to just rotate about the y-axis here, and we just have a look at how it look like. Okay, so here you go. And you will see that, okay, this looks a bit weird. This shape here, it looks like a, you know, a hut or hat. This look more like a hat here. So we're going to use camera view. I'm going to put this as, let me see, phased out X-ray. Okay, maybe X-ray works. Okay, great. There you go. So it looks something like that. Maybe too many lines there. Smoothen the edges. There you go. Okay. So we'll get this shape here. I'm not sure whether you can see how is it like. So there's this, we need to minus off the one inside here, definitely. So this area here, we need to minus it out. So this volume here, sorry, this inner layer here, that we need to minus out. Okay, but the outer volume, which is the interesting one. So one made up from the top here, which is here to here. Okay, this top. And after which there's another one which is the bottom one, which we need to consider. Okay, so the shape that you're looking at is essentially, let me just draw it out, what we want for part B. So since this is just maybe I just snip it out, hold on. So the required volume, I hope we can see all of us required volume. Okay, would be taking this shape here So taking the green shape outer layer, so this part here, this volume here on top. Okay, so this shape here, I can just take the copy. Okay, and this bottom shape here, so this shape is like something like that. This bottom shape here, so it looks something like that, right? You can just mix them like that. And minus off the inner shape inside here. So this let me just do this inside curve here. Okay, it's something like that. Okay, so let me just there you go. So you just take these two shapes, minus of this case here. Let's look at our model. So I hope you can see why we need to add from here to here, and the bottom part here. See this bottom here. So we integrate this line here with respect to y. You get this if just with respect to y is this strip of area here, sort of like a trapezium. Then you rotate about the y-axis is everything except for this inner thing taken out, right? So it looks something like that. This one here. Then you just add these two and minus off the here to here. Okay, so let's try and write down the integral for each of this. So the first one, this top integral here will just be from pi. It's just pi. Let us just label each. So this would be, let's say this is y1, and y2 would be, this is y2. Okay, so because this curve here is y2, so this is x2 as well. So I'm using dy, rotate about y-axis. So this will be x2 square from 0.07754. So from 0.07754 to here is 1. So because we have this over here, this is 1, this is 0.07754. That will be 1 here. Okay, so done. So I've gotten this. This is this over here would be this volume here. Then we're going to take the bottom volume. The bottom volume would then be using this curve here. This is x1. So we're just going to add pi x1 square dy. Okay. Same thing. We start from 0. So this is 0 here. Then we end with 0.07754. So because it starts from 0 here, so this is 0.07754. Great. Then the last one, which is the one which you need to subtract out, which is the one inside here. Okay, the one inside here, that will give us minus of from 0. This is 0 to 1. This is 0 to 1. So this curve here is a very simple curve, which is actually y1 is pi x1 square. This will be 0 to 1 dy. Okay. Now, but take note of this because there are two curves for x here. This is a very important part. You have two curves here. Okay. For curve here, this part here, x1 can be equals, so when you make x a subject for this, because if you look from y-axis, you actually have two equations for the x value. One is on the left tail and the other one's on the right tail. So this case here, this will be plus minus square root y equals to x plus 1. So x equals to 1 plus root y, or x equals to 1 minus root y. So this is, both are x1. So it doesn't take long for you to know that actually this curve here, the negative, because x is 1 minus, so this is 1 minus root y. This will take this curve here, right? So maybe I just label this out, x1 for this part. this will take this side on the right. So this is for x less than 1. We take this equation. X bigger equals to 1 will take this equation here, which is this part here. Okay, I know it's a bit confusing, but just follow me. Because these both x1 will use different function. Okay, so let's just write down the x1 that we want. So for this case here, pi, this is 0.07754. This is 1. X2 square will just be this. So I'm going to just make x2 the subject. So it's ln y2 equals to 2x2. x2 equals to half ln y. So this is just half ln y square dy. Yeah, so I think that's about it. Then plus the other one would just be pi 0 to 0.07754. Now this x1 here, this curve here would follow this equation, which in turn mean that we are going to use 1 minus root y square dy minus pi 0 to 1. So x1 will be here. x1 will be here. So then x1 will then be 1 plus. Okay, this is 1 plus root y square dy. There you go. So there you go. This should be your answer. I am going to just key in calculator. Just key in calculator and we'll see what we'll get. I realized I made a careless mistake in my working here. So please have a look here. This is minus. This is minus. Okay, so I'm just going to add a minus to all my equations. Minus 1 minus x. So this is minus, and the sign is still the same. What do you call it? Still the same equation. So it's fine. Just make sure to just add a minus there. So a key in calculator. This will be the this integral here. Add this both up. And minus of this. Okay, and I will get 0.559284. So this is 0. So 0. The reason why I realized I had a careless mistake is because I was having a negative volume. So once you see a negative volume, you know that something may be wrong. So negative 0.55928. 0.55928 cubic units. Okay, so this is 0.559 cubic units. Alright, so that's how, giving your answer to correct to 4 decimal places. So this is 3 4 dB. Okay, so that's how I do this question here proficiently. So let's look at the subsequent part. So let's look at the subsequent part C. So a curve C has this parametric equation here. The line L has this equation, meets the curve C at point minus 2, 1. So this is line L here. This is the curve here. Okay. The region S is the region enclosed by line L and C, and the x-axis shown of the diagram below show that the x-intercept of curve C is negative 2, root 2. I think this is pretty okay. At the intercept, at x-intercept, alright, you know very well that this will just be y equals to 0. Now when it comes to parametric equation, the parameter is important. So at x-intercept, what we need to do is y equals to 0, and what I need to do is I need to find what is my parameter which corresponds to y equals to 0. So when y equals to 0, this will give us 0 equals to sine t over 2 plus cosine t over 2, meaning to say this equation here becomes 0. This becomes 0. Right? So that is a point there. So once I've done this, this will be minus sine t over 2 equals to cosine t over 2. So very simply, I could just divide both sides by sine, cosine. Then this will be tangent t over 2 equals to 1. So divide by cosine t over 2. Then this case here will be tangent t over 2 equals to negative 1. So here, t over 2, basic angle will just be tangent inverse positive 1, which is actually just pi over 4. So t over 2 will be, because it's -1, it can be in quadrant 2 or quadrant 4. Really depends. But our t is t over 2 here. So divide by 2. So t over 2 with -3 over 4 minus pi over 4. Okay. So this is in minus pi to -3 over 4. Yeah, it's actually in the sort of like in the third and the fourth quadrant, right? So this case here, I'm just gonna take this as quadrant 2 would be 3 pi minus pi over 4, or pi plus pi over 2 pi minus pi over 4. So this is 3 over 4 pi, or 2 pi. So this will be 2 minus, that will be 7 over 4 pi. Okay. This case here, you could just okay, negative, right? So I'm gonna just minus of 2 pi, because it's the same, minus 2 pi. This is 3 over 4 minus 2. This will be minus 5 over 4 pi. This same thing, minus 2 pi. Just to check. So that will be negative pi over 4. Okay. So minus 5 over 4 pi is obviously not within this range here. Okay, reject as t over 2 is between -3 over 4 pi and pi over 4. Okay, so in other words, we need this. We really need this one here. This is what we need. This case here, hence t over 2 equals to minus pi over 4, and t equals to minus pi over 2. It's just trigo. Okay, so once done, we need this x-intercept here. So x equals to 2 sine. So we are going to just substitute this t over 2. So 2 sine x equals to 2 sine t over 2 will be minus pi over 4 minus cosine minus pi over 4. This will just be 2, negative 1 over root 2. This will be positive 1 over root 2. So this case here will just be 2 minus 2 over root 2. Rationalize the denominator is pretty okay. Multiply root 2, multiply root 2. This would then be negative 2 root 2. Okay, so 2 marks. Try. Okay, let's look at part 2. So let's look at the last part. Find the exact area of S, meaning this S here. Okay, so we're going to find, I'm just label all the points here. Now it's very good. So this is minus 2. It's always good to just write down the parameter which correspond to each point first. So for example, we already find y equals to 0, t is minus pi over 2 here. Right, so this is t equals to pi minus pi over 2. This point here, this corresponding point here, t is minus pi over 2. Alright, so if we want, okay, very likely we need to find what was this t later. But we just try and see how do we find the exact area. Find exact area meaning we need to use use integral. We can't use calculator. So exact area of S, what we need is actually what I would suggest. We could use with respect to x here as well. So I just took this triangle here minus of this small triangle here. Okay, the one below here. So here I'm gonna just write this down. Here I'm gonna take this sort of this quadrant here. So I just take this quadrant and just copy this area here. Okay, so this quadrant here, maybe I should draw it nicely. Okay, so this quadrant here, copy it. This is what we need to find. minus of the triangle here. Okay, so this case here is like that. All right, so what we're going to do here is going to just find out this is 0, and then after which this over here, this is a line equation. Just this will be y equals 0. I think very quickly we can find out what is this point here when y is 0. X is just -5/2, so this is -5/2. Okay, so let me just erase this away because we don't really need that now. Great. This area is negative area. Remember, this is below the x-axis, so you can just do this integral here. All right, you start off with this -2 here. We will start from we're gonna mod it actually. Just integrate from the smallest. So this over here, the x-axis here is we found just now -2√2. So we start from -2√2 to 2. -2 here. 2 to -2. So you start off with the smallest to the bigger value, and after which we're going to use this y dx, right? So it's y dx here. Okay, this y will just use the y of the curve here later. Okay, we're going to use the y of this curve here. Then we're going to use this triangle. This triangle is pretty simple. This triangle is just base times height. This height here is just 1 unit. This is just 5/2, just -2 minus 5/2. That will be half. Okay, so the length here is half. The height here is 1. All right, so just remember to mod this, because this we're going to use geometry to find this triangle. So this is just -half times half times 1. So you use if you're using integral, just make sure that this area below is a negative area, so you should know that to mod it. Okay, so what we're going to do next is this. We're going to change it to parametric form. So to change the parametric form, this is where this is important, because a lot of times students forget. Now when this is x, this will be x equals to 2, this is x equals -half. So this now we need to change this to the parameter. Okay, so everything now need to change the parameter. I think for the y is easy to change. The y, we're just going to copy the whole thing here. So cosine, what is that? Cosine, sine t plus cosine t. All right, so that will be sine t plus cosine t over 2. So sine t over 2 plus cosine t over 2 there. Then dx dt, we're just going to differentiate this. So dx dt just be 2 cosine. So this is half. Oh, very nice. Plus sine half as well, sine t over 2. So this will just be cosine t over 2 plus sine t over 2. Okay, so dx would then be cosine t over 2 plus sine t over 2. Now I know some schools wouldn't allow you to write this, but I don't really think it's an issue, because a lot of textbooks, I'm talking about university textbooks, we do write this down. But if you don't allow, then just don't write it. Okay, so it's just make sure that you grade it out. If your school doesn't allow, I don't think because in order to do the rest, it's gonna be, we need higher, like more advanced algebra to do it. So we're gonna look at dx. This will be cosine t over 2. Just make sure that we differentiate this correctly. So cosine, this is cosine t over 2, and that will be plus sine t over 2. Okay, and this is dt, right? Dx dt cosine, yeah, great. So now the problem is no longer the it is a parameter. So at x equals to -2 over root 2 here, we know that the parameter, corresponding parameter, is -pi over 2. So that is pretty okay. -pi over 2 here. this parameter is the one which is a problem. So when x equals to -2, when x equals to -2, we know that this is -2 equals to 2 sine t over 2 minus cosine t over 2. Now this looks complicated. This one doesn't seem like we can solve this because it's going to take for a while. So I would suggest we use when y is equals to -1. Then when we use y, that will be -1 equals to sine t over 2 plus cosine t over 2. Suddenly, we can just add them up. So just add them up, add both of them up, and we will get -2 plus equals to 2 sine t over 2. So sine t over 2 is just -1. Okay. Now remember, just now previously t over 2 is between -3 quarter, -3/4 pi and negative pi over 4. So we inverse this, you will get actually negative pi over 2. Okay, so you just use your calculator, you will get second inverse, -1. You can have -90 is negative pi over 2. So that is it. This is within the range, so t is actually minus pi. Alright, so in other words, this case here, this is actually minus pi. Let's take note of that. So there you go. We can. So now this area will give us negative area. So just make sure when you open up the modular sign, or if you don't want to open up modular sign, it's fine also. But this would just swap. Okay, because this we know will be a negative area. So this will be, I'm going to expand this sine square t over 2 plus 2 sine t over 2 cosine t over 2 plus sine cosine square t over 2 dt. It's 1/4. Okay, 1/4. Yeah, okay, great. So then this would just be 1. These both will add up to 1. Because cosine square a plus sine square a is 1. Right? This will just be 2 sine a cosine a equals to sine 2a. So when I change my equation here, what I'll get is minus pi over 2, 1 plus sine t. Wow, great. It looks good already. So this case will be just t minus cosine t minus pi over 2 minus pi minus 1/4. That will give us minus pi over 2 minus cosine minus pi over 2 minus pi. Moment of truth. Cosine negative 90 will be 0. So there will be minus pi over 2 minus of cosine minus 180 will be negative 1. So this will just be, okay. So expand everything out. What we'll get is pi over 2 yeah. So yeah, it's a positive answer here. So this is square units. Yeah, I don't have the final answer here. So if you have any question or comment, please do let me know. It's a very interesting question. For this question is actually quite a long question here. Just make sure you're okay with most of the steps. Alright, so any question or comments, please let me know, and I'll see you in the next question.